Hello the internet and welcome back to my channel. I have an ONKYO receiver today on my bench and it's the one that I've showed you on this video. It was working on that video, so why is it on my bench? When I got this receiver, I just wanted to test it. I wanted to make sure that all the inputs were working, everything was okay, and maybe find another home for it. So I wired everything in and I plugged it into a monitor, into some speakers, and I couldn't get any audio out of it. So I started playing with HDMI cables. I got my PlayStation instead of my laptop. I thought it was some kind of, HDMI quirkiness. And at some point I got the sound, I got the picture, and it was working totally fine. I tried all the inputs and it was fine. And after that, I made that video that you saw, which was showing some cooling issues with the device. But happy days, the device was working, I closed it, and I started looking for someone who might wanted it. Eventually, I found someone who wanted to take it home, so we agreed on a date, and the day before that this ONKYO was supposed to be collected, I wired it back again to make sure everything was working, and I thought I'll leave it connected so I can show the buyer that this is working, so, you're a bit more comfortable in taking it home. And once again, I wired everything and I couldn't get audio out of it. So I started fiddling with the HDMI cables again, and the player, the PlayStation, the setting, turn it off, turn it on. Eventually I got the sound, but then, I got this little yellow flag out of it, and I thought, is this actually working? Because these things are supposed to fail exactly in that way, when the sound disappears, but everything else seems to be working totally fine. So I decided to leave the ONKYO wired with my PlayStation, the monitor, everything, and everything was working. So I switched everything off and I came back the following morning, I turned everything on, and I was expecting to see it working because I hadn't touched absolutely anything. And guess what? No sound again. So I had to get in touch with the buyer and say, look, I'm sorry, but this is actually not working and I can't sell it to you. Sorry for wasting your time. They were pretty understanding. But yes, this ONKYO is not working. Now, what fault am I talking about? Now, when it comes to ONKYO and I think Denon, they install an IC within the electronics, which unfortunately has been recalled by the manufacturer, by Texas Instruments. These very receivers were all recalled by ONKYO. Were not recalled, but the ONKYO extended the warranty because of this very issue. So what happens is at some point you turn it on and you don't have audio. You might have picture going through, but you don't have any audio whatsoever. And the IC responsible is this little one here. You can call it in many ways. The HDMI IC, the Dolby DTS IC, the DSP. This is actually an ARM DSP. It's a CPU, it's a processor. It comes with RAM, it comes with BIOS, and it runs Linux. I'll show you in a minute. And when that fails, the whole DSP processing of the unit stops working and the receiver will refuse to pass audio because obviously the DSP itself is not working. Now, there are many videos online who tell you how to fix these things, and they all involve heat. If you heat it up, you put a lamp on top, you reball, you reflow, and that usually works maybe for a while, but then it kind of stops working after a while. It's kind of a similar issue that you have with the PlayStation 3 or the Xbox 360, even though I'm not entirely sure what's going on within the IC internally that causes this problem. So on today's video, we're going to take a look at this problem with this chip. We're going to do some more advanced diagnostic. We try to understand what's going on with the IC, and we'll try to answer the important question. Can we fix an ONKYO receiver which has no sound? So keep watching if you're interested. Let me thank today's sponsor, PCBWay, and now let's dive into this HDMI issue. The chip responsible for this problem is this one. This is manufactured by Texas Instruments and it has the Dolby and DTS logo on it. That's because these contains and uses Dolby and DTS licenses, products, codecs, whatever that is. Now the IC in question is D830K011AZK. Now Texas Instruments at some point released a bulletin where they were basically acknowledging that the B version of this IC, so that would be the D830K0 blah blah B ZK, was defective. It was dying prematurely. So they recall those ICs and they recommend replacing those IC with revision D. So that's going to be D830K013D, etc., etc. ONKYO, as a consequence, extended the warranty of these devices. I can't remember all the details, it's been quite some time. But back then, when one of these devices would fail under warranty, ONKYO would either swap the HDMI board, which is this whole board here, sometimes with the same IC, which unfortunately was prone to fail again, sometimes with the new version, with the D version. And you can find online pictures of these HDMI board with these DSP which says new on it, and that was the D version. Now, apparently the D version just works, so that's unaffected by this problem, and the B version is more or less failing around apparently 18,000 hours. That's what people on the internet seems to be noticing. When this IC fails, the whole DSP fails, as I said, and as a consequence, the CPU will refuse to activate the outputs, because the DSP is either not working, not responding, or not responding the way the CPU is expecting. Now, unfortunately, I cannot find a bulletin online. I have seen it with my own eyes years ago, but right now I can't find it. I looked online for hours, and it's not on Texas Instruments anymore, and I can't find it with any Google or any search engines. So unfortunately, I can't find it, but I do remember seeing the B version being identified as faulty. Now, this is not the B version, this is the A version, and all this information I've collated together is actually coming from repairalmostanything.com, where a very nice user, TJmotter, has put together a number of very useful posts, including this one you're seeing on screen right now, where I've got most of this information, and he claims that the A version is as bad as the B version. That being said, I kind of remember that the official bulletin from Texas Instruments was not mentioning the A version, was only mentioning the B version, but I'm going by memory, I might be mistaken on that. Now, this IC is BGA, and you know how much I love BGA, so replacing this IC is not a trivial task, but we'll think about that in a minute, and we need to understand what we can do for that. But before we get into that route, I'd like to show what happens with this receiver, which, by the way, I haven't turned on in a while, so hopefully still behaving the same way. And then I'll show you an interesting extra, like, advanced diagnostic that I found with the help of TJmotter online, of course, which is quite interesting in seeing exactly what happens when that IC fails. Alright, I've got a small speaker connected to one of the main channels, I think it's the left channel, and I got some signal, that should be something like 1 kHz, going into the CD input of the ONKYO. So when I push the on-off button here, you will see here on the left-hand side the diagrams of the speakers connected. Whether they are connected or not, that's another story. When that happens, there's a click happening at the same time, and then you hear the 1 kHz tone coming out of the speaker. Let's try that. So that's exactly as I said. What happens when the HDMI chip fails is that the DSP fails to communicate with the CPU, and you never get that diagram of speakers connected, and hence you don't get any sound coming out of the unit. Now, last time I tested this machine, that was a few months ago, I found there was a way to trigger this working, non-working situation, and I'm sure if you follow my channel, you know what that is. Cold spray and hot air. When I was cooling down the IC, it would stop working. When I was warming it up, it would start working. Obviously, you have to do that before you power on, because the CPU is waiting for some initialization, I guess, commands from the ARM processor, from the HDMI IC, and if that doesn't happen, I don't think it happens while the unit is working. So let's try that. Let's turn this off again. Let me cool down the HDMI IC, and then we'll try and turn it on again. Okay, let's try again, turn it on. And as you can see, there is no sound and there is no diagram of the little speakers on the display. So that is telling me that the DSP is not working. Now, how do I wake it up? Hot air. Let's try that. Let's try now the IC is hot. There you go. So I realized that I can trigger that very accurately every single time. I can cool it down and it stops working. I can warm it up, not too much. It's just 200 degrees from far away and it starts working straight away. Now, my experience with this IC is a bit different because usually when it works, it works. And when it doesn't, you might need to warm it up quite a lot. At that point, it works for a while. So that's a bit weird. I have an idea of my own, which I'll share later on. But that's kind of a weird behavior, which I haven't seen before on my many ONKYO receivers, which I've tried to repair over the years. Now, that is nothing special. Everybody can show you this. There's probably videos online kind of showing you something like that. What I'd like to show you is something more cool from my point of view. This little white connector here is a serial port which connects to that CPU, and you can see what it's doing when you press buttons, when you start things, when you cool it down, and when you warm it up. So let me wire a serial port to that connector, and we'll have a look together on how that CPU behaves in all the different circumstances. When it comes to sound, there's plenty of projects online you can download and build yourself. And if you need a PCB, well, PCBWay is definitely your stop. I've been using PCBWay on my channel for my projects. I can definitely recommend the quality of their PCBs and the quality of the customer service as well. The process is extremely simple. You just need a Gerber file of the project you're looking, download it, upload it on PCBWay.com. The system is more or less automatic. You don't have to do much. I tend to change the color of the PCBs, choose a postal service, and the PCBs will be delivered at your place. But if your project requires a 3D print, for example, well, PCBWay can help you with that as well. And also CNC machining and metal sheet fabrication. So it's a big stop for all the needs for your projects. And the 7th project design contest is now on PCBWay.com. There is time until the 19th of January 2025 to submit your project. So whether you want to submit something or just take a look, have a look at PCBWay.com. For all the details, take a look at PCBWay.com. The link is also down below in the description. And let me thank PCBWay for sponsoring my videos and my channels. Their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with this ONKYO. Alright, so I've wired my 3.3 volts serial adapter, the one I use for the PlayStation 3 and the PlayStation 4, to that connector. And the schematics are available for this ONKYO, so you can find the pinout from the schematic itself. I basically wired ground, TX, and RX. And if it doesn't work, you just swap the TX and RX around. That usually can happen. I've got PuTTY running on my laptop, which is listening to the serial port. Let's turn it on and see what happens. And you see, this is an ARM processor, it's running U-boot and it's running Linux. It's doing a number of things. There you go, you got this command here. Let me mute the output. Then Linux will do some stuff like keep doing its things, looking for USB sticks. I can see, will do things in the background. But for example, now I'm on the CD input. If I'm changing the input and look at the logs, I'm clicking it now. You see that there is a net app, blah, 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 called selector 4, and it's changed to a different input. And if I'm going back to CD now, there you go. You have something happening there. It's just the DSP changing. I don't know. I don't think it's the DSP changing the input, but it's obviously changing something. The most interesting thing I see is when it actually starts, you can see that this thing is running on 64 megabytes of DRAM, even though here it says 32. I'm not sure what's the difference. You can see it says loading from NAND, 32 megabyte, 3.3 volts, 8-bit. It's an ARM Linux kernel image, which is uncompressing, is running. There's a mentioning that this DA830 version 1.24. That's the version, the model of the DSP itself, 830 blah 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 from Texas Instruments. And it's running Monte Vista Linux Professional Edition 5.0. So this is pretty cool, and by the way, the IC was working every time we had sound, so that's a healthy booting process of this unit when everything is working totally fine. What I'm going to do now, I'm going to cool down the IC and turn it on again and see what do we see on screen when the IC doesn't work. Turning on, 3, 2, 1, go. And as you can see, the IC is trying to start, but it basically stops almost immediately. If I remember right, it changes every time. So it looks like it's kind of crashing. So right now, it literally at the very beginning, when it's loading the bad block table for the RAM or something like that. Let's try and turn it off and on again. 3, 2, 1, go. There we go. This time might be working. I think it is working, yes. Yes, it is working. So let's try and cool it down again, see if it stops in a different place. 3, 2, 1, go. There we go. Now we have a read error. So it actually stopped the process. Now it is interesting to notice that when it refuses to post or boot, whatever you want to call it, it looks like there's always an issue with DRAM or NAND. In this case, which has failed to boot, it's reading, what's that, 4 GB of RAM, 3088 megabyte of RAM, but earlier on when it was working, it was only reading 64, which is, I guess, it's totally fine for an old sound processor like that. So yeah, I'm also kind of wondering whether it could be a RAM problem, even though I'm only cooling down the IC. I really don't think it could be a RAM issue. And again, that IC is notorious for failing, so obviously it's the main suspect when something like that happens. But this is quite interesting. Now, how do we fix that? And I know that many of you are watching this video are probably skipping to this point. How do we fix that? You check online, you find reflowing, reballing, but apparently those versions of ICs are actually deemed as defective from the manufacturer itself, which is not ONKYO, it's Texas Instruments. So the solution is to replace the B version at least, and apparently even the A version like that one, with a D version. The D version is the one which was fixed by Texas Instruments, so it doesn't end up behaving like that. Now, the problem is that Texas Instruments never sold those ICs to anybody but ONKYO, Denon, and all the OEMs which were basically licensed to use those ICs which had Dolby and DTS technology inside. So obviously it's not something that you could buy from anybody else. So according to TJmotter and that very long thread on repair almost anything, it's impossible to find a reliable source of ICs which are not scavenged from other units or rebranded, relabeled, whatever. And apparently buying those ICs from AliExpress is completely pointless. Now, over the years, I tried to fix another ONKYO receiver, which is still sitting under my desk, which has exactly the same problem. It's the same IC, and that time I reflowed it and it worked for a while, then it stopped. I reballed it worked for a while, then it stopped, and then it completely stopped. It was just completely broken, and I went on AliExpress and bought another one. Now, unfortunately, I waited like 6 months before I decided to solder it on the PCB, and that never worked. So I couldn't obviously go back to AliExpress and say I wanted a refund. Those ICs on AliExpress are available. The B version, the A version, the D version, everything is available, but it's not cheap. It's about £30 each, and I don't feel like giving it another go because it's probably like wasted money, especially even though this is a very high-end sound receiver, it's not worth so much money in 2024. That being said, even though Texas Instruments never sold those ICs to like private users or anybody else but OEMs, well, those ICs were manufactured in China, and now it's 2024, and chances are that some of those AliExpress sellers actually have some genuine ICs because it's just a leftover from manufacturing back in 2010 or wherever it was, and those might actually work. The thing is, how do I know which works and which doesn't? So the first question I have for all my viewers is, do you know, are you aware of a reputable, reliable seller on AliExpress or wherever it is, where I can buy one of those IC Revision D, which is gonna work on my receiver? Because, you know, if I could fix it, I'd love to just revive this thing because it's huge, it's nice, it's cool, and I don't want to throw it away for just that little IC. However, well, that is revision A, is not revision B, and even though TJmotter says that revision A is as bad as revision B, I don't remember reading that on the bulletin which I read from Texas Instruments. In all the years I've experienced issues with those ICs, I never had this weird behavior where I can repeatedly make it work or non-work with cold spray and hot air, and most of the time, as you can see, this is working. So, because honestly I haven't got many chances besides going on AliExpress, close my eyes and buy an IC and hope that it works, I go ahead and reball that thing anyways. I know, it's probably a waste of time. Also, I'm not very good at reballing, I'm not very good at BGA, so there's a very high chance that I'm gonna destroy everything and I'm not gonna be successful. But honestly, this receiver has been on my floor for months and I need to decide what to do. Either I can fix it or I'll just, I don't know, throw it away, give it for free, reuse the heatsink, reuse the components, I don't know. But right now, what I'm gonna do, I'm gonna try and remove the IC, reball it, reapply it, and if it works, once again, it doesn't mean that it's gonna work for a long time. It might be temporary. So let's remove the HDMI board and let's get ready to remove the IC, reball it, and reapply it. Here we go, BGA again. It's my nightmare, so I'm not expecting too much. The HDMI board where the DSP is located is removed and spent the night in my dry box. Probably not enough to have any effects, but anyways. I now faced the first massive issue. The board is studded with electrolytic capacitors. Not only on the top, but on the bottom as well. Those capacitors will explode for sure, it's facing the heating element when desoldering a lead-free IC, so after some consideration I decided to wrap most of the PCB in kitchen foil, basically covering all the capacitors on the PCB, leaving out only the area around the IC, which thankfully is free from capacitors. This is not ideal as the board should be heated uniformly or it will warp, but I don't see any other options besides removing the capacitors or just replace those which might get damaged. The PCB is also longer than my preheater, so a third of it ends up not being preheated at all. Again, not ideal. On this rework, I'm gonna use a new thermocouple I've been recommended. It's semi-rigid and apparently more accurate than the usual ball-shaped thermocouple, as it can be bent to increase the contact area with the PCB. In fact, this is the first time I'm going to trust a thermocouple at all, rather than my infrared thermometer. The preheating process goes in stages. At each step I give the PCB plenty of time to get to temperature, particularly because of all those connectors and bigger ICs. With higher temps I reduce the soaking time as I don't want to keep the PCB at very high temperatures for too long. The new thermocouple seems to be working. It usually reads 20 or even 30 degrees higher than the ball-shaped one, and it's very close to what my infrared thermometer is reading. At around 180 degrees I begin with hot air, and when the thermocouple reads 230 degrees the IC seems to be floating and I remove it with the small suction pen. I am impressed. So far I don't see any damage and I haven't heard any popcorning noise, indicating there is no damage to the PCB. While the PCB is still hot, I mix some leaded solder with the existing one and then wick it away with solder wick. Using my small preheater, which I have shown on this video, I repeat the process on the IC as well. The IC then gets cleaned and inspected. I see what looks like flux residues on some pads, so I manually scrape them to make sure that nothing gets in the way. Despite having a reballing jig, this time I decided to go manually. It's a small IC and I was curious to see how complicated that was. It wasn't too bad, not exactly relaxing, but it didn't take too much. I chose 0.55mm solder balls, they seem to be more appropriate than 0.6mm ones. Then I turned on the small preheater and it's nice to see the balls melting by themselves. A little help with the hot air gun and they're done. I've learned that at this stage I need some more flux to make the solder bonding perfectly and look shiny. Once the AC has fully cooled down, it's time for a wash and also time to remove the fibers left behind by the cotton pads. Don't use cotton pads on those ICs. The outcome is perfect. No damage, the balls are nice and shiny, I am impressed. The PCB also seems undamaged. I don't see any blisters or scratches or damage on the solder mask. Though the area under the IC is full of wires and I'm hoping they won't be in the way. It's now time to reattach the IC. This time I'm using the microscope as a second camera. I cannot use too much flux under the IC or the IC will float away when it liquefies. I will apply more later. To flow the solder, I followed the same temperature profile, but this time I aim at about 200 degrees and not 230 degrees as before. It's much easier. Most of the work is done by the preheater and the hot air is only used at the end. When I reach 180 degrees, I apply some hot air and within seconds I see the IC sitting down. I'll speed up the process back and forth a couple of times now so you can see it. While the solder is still molten, I add some flux and keep the solder molten for a little more. I want the solder to bond with the pads perfectly. That's it, now it's time to wait while everything cools down. Once the PCB is cold, I notice a lot of solder balls under the PCB where the IC is located. I think that came from the vias under the PCB, which I unintentionally filled up with solder when I used my soldering iron to remove the existing one. I see lots of potential for shorts, so I spend a little time with a small soldering tip removing those balls. But I'm not happy to see that. Are those extra balls also under the IC? Are those balls coming from the IC instead? I don't know, but I have a bad feeling. Cleaning the sticky goo left behind by the flux, which is a genuine Amtech, takes some time. I also flush the IC with isopropyl and use my air compressor to try and push out the excess from under the IC. I then inspected the solder balls with my microscope. The side areas that I can see seem to be very good. I'm only concerned about this one. Is this via supposed to be joined to the solder ball or is it shorted? Well, it's hard to say and it's one via out of 300, so I can only make sure that 0.9 volts and 1.2 volts, the supply voltages for the IC, are not shorted to ground. The supply rails are not shorted, so I can only fit the boards back and give it a go. Alright, everything is back together. I'm really happy with how it went, though I'm not optimistic now. I think that chip was already faulty, so chances that it's still working are slim. Chances that it's working better than before are even slimmer. But let's see what happens. I've got a signal coming in, a speaker connected, and I monitor the serial output of the ARM processor. Will it work? Let's find out. Let's turn it on in 3, 2, 1, go. No. Let's turn it on in 3, 2, 1, go. It's working! Ooh, look at that! It's actually working! And it's working! Wow! It is working! I'm going to have dinner. I'm too happy. I am incredibly happy with the outcome. This is probably my second successful reball, and the first one, if I remember right, and I might have some footage about that, is exactly an ONKYO receiver where I reballed the same IC and it worked for a few months and then it stopped working again. As I said, this is not a fix, unless on this model, for whatever reason, the BGA was actually the problem. I guess I will know within a few weeks or months, but it might take a while to fail again, so chances are I will never know. Well, the question that now everybody is asking is, will it work when it's cooled down? Well, let's try this. So this is totally working. I'll turn it off again, give it a few seconds, and let's cool down the IC and see if it then starts up again or it crashes like before. Power on, 3, 2, 1, go. Okay. Whoa. I think it's working. Yep. Try a bit more cold spray. 3, 2, 1, go. Amazing. Let's try this one last time. 3, 2, 1, go. It's working. It's amazing. Now the question is, what do I do with this? Because it's working, but honestly, I don't think it's gonna last. So what I think I'm gonna do, I might wanna find someone nearby that wants it for, I don't know, like 20 pounds or 50 pounds, something like that. I say, look, it's a reasonably good receiver. It can do 4K and Dolby Atmos, but it can do all the lossless formats like DT-SMA and Dolby Through HD. It's really powerful. It used to be top of the line back in the days. I would like for someone to use it, but honestly, I don't think it's gonna last more than, who knows, maybe it's gonna last for a few years. I have absolutely no idea. I just don't want to throw it away, especially if now seems to be working better than before. Once again, if someone knows a reliable place where to buy those IC, the revision D of those IC, that would be great, because I could replace it on this one. And I have another one under my desk which needs one of those ICs, and my own ONKYO receiver in my home theater has the B revision of the IC. So it's a ticking bomb in my soundtrack waiting one day to be turned on and come up with the usual dreaded no sound because of the HDMI IC. Now I'm wondering whether to extend the life of that IC, a little heatsink could be a good idea, because I believe that IC is running pretty toasty, and especially this is an amplifier, chances are it might run in an enclosed space, so that IC is, I think it's going to run about 60-70 degrees all the time. With an IC, with a heatsink on top, you're probably able to reduce the temperature by at least 20 degrees without anything. I've always had an IC on my ONKYO receivers on that IC, because I know it's kind of fragile. Whether that works or not, honestly, I am not sure. I can only assume or hope maybe that a lower temperature might delay the fault from appearing at some point in the life of the receiver. I guess we reached the end of the video. I'm incredibly happy with the outcome. If you follow my channels, you know that BGA is not my best skill, so this is absolutely amazing. It was a great exercise. As a plus, the ONKYO seems to be working for now, so happy days. If you enjoyed this video, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget, I'm also on Patreon, and the name of my patrons are scrolling at the side of the screen. Thank you very much for your support. It's absolutely amazing. There is a free tier if you want to join my profile on Patreon. If you don't want to join Patreon, which is very understandable, maybe you could buy me a coffee down below. There's a link in the description. If you don't want to buy me a coffee, your visit here, it's absolutely fine. I appreciate your time. A like, maybe a subscription, that would be absolutely fantastic. Well, that's it for today. I wish you a great day and hope to see you again soon here on my channels for my next videos. Thank you very much and goodbye. Bye-bye.